Hi there, I'm Shazad. So previously, I talked about the different kind of signal that are generated from the specimen when the high energetic electronic beam incident on the specimen. So here in this video, I'm gonna talk about the secondary electron yield in scanning electron microscope. So this secondary electron yield is represented by the symbol delta. So let's talk about the secondary electron yield in SEM, the delta. It is a ratio of the secondary electron current, or you can say the number of secondary electrons emitted, or maybe you can say the total emission current divided by the primary electron current or the incident electrons. The delta delta has a value either greater than 1 or less than 1. So let's talk about the factors affecting delta. So first point is the energy of incident of the electron beam. This is that is coming from the electron gun. So the energy of the incident beam is the one of the factor that affect the yield of the secondary electron. So second point is the state of the irradiated sample's surface. What does it mean? It means uh, the the secondary electron yield depends on the sample surface. Means what kind of sample you are using, uh, maybe the conducting or non-conducting, or maybe the uh, semi-conducting. So third point is the electron beam angle of incidence. So the secondary electron yield further depends on the angle of incidence. What kind of angle, the angle of incidence you are using to to take the images of SEM images. Fourth point is the chemical composition. What does it mean? It means what kind of composition your sample has. Means the chemical composition, the electronic arrangement in your sample. So this secondary electronic yield is proportional to the cos theta to the power minus n, where n is about 0.8 for heavy elements, whereas for light elements it is about 1.2. So here here in this image, uh, you can see this is your specimen, and here is the incident electron beam that is coming from the electron gun, and this incident beam strikes the sample surface, and we have different kind of signals as I talked about in my previous video. But here my concern is on the secondary electron. So here I just want to talk about the secondary electron emission from the sample surface. So here you can see this is the backscattered electron, and the angle made by this incident beam with the backscatter electron is theta be. But I don't want to discuss about this here. My concern is on the secondary electron. So here you can see this is the theta se, and this is the angle between the incident electron beam with the secondary electron emission. So we have sort of this sort of signals here. Just right there we have we have a detector to detect these kind of signals, the secondary electron based, because the secondary electron has less energy compared to the backscatter electrons. So this is the inelastic collision on this backscatter electron, maybe the uh, your elastic collision. So this is all about the secondary electron emission. One more thing, I just want to discuss over here is the conduction electron density in metals is high. So the secondary electrons have a low probability or the possibility of escaping the surface of materials. Uh, but in case of the dielectrics, the concentration of the conduction electrons is low. So which leading to or the possibility of the escape of secondary electron is greater in case of the dielectrics. So in case of metals, because we have large number of electrons or the electron density, so there will be more collision. More collision means we have less mean free path. Less mean free path means uh, we have less chances to get the secondary electron towards the detector. So here in this image you can see this is the yield versus the energy of the incident electron beam. For the lesser energy we have more yield. Here you can see at 1 kilo electron volt we have a higher yield as compared to higher energy regime. So if we take this window more than 1 2 electron volt, that means we will have a lesser yield. So here delta represent the the yield of the secondary electron, and this is the yield of the backscattered electrons. Just right there you can see this is the combination of this the secondary electron and the backscattered electron. So big at less energy we have higher yield. That means if we increase the energy we will have more collision between the electrons and less mean free path, which gives us uh, less yield. It will never reach towards the detector that will detect the secondary electron. So bottom line is, what are the factor affecting the yield of the secondary electron? So in this slide, the previous slide, I talk about this the energy of incident electron beam first. The second is the state of the irradiated sample surface, means the type of your sample, maybe the semiconducting, conducting, non-conducting. And the third point is the electron beam, the angle of incidence or the chemical composition. So if we have a the larger the theta, l- greater will be the yield, because this secondary electron has less energy and the detector position is right there, just right there. So, so in total, if you want to get the better SE image, you have to maintain the inclination of your sample. Okay, so here uh, if you like the video, don't forget to like, share and subscribe. Please share it with others. If you don't want to miss latest videos or latest updates on my channel, you can press the bell icon. Thanks a lot. Bye.